Okay, so some definitions, books are different about this. Some books call a binary operation just a pairing of two elements on a set. So in this particular definition, they call a binary operation something that maps a set across a set into the set itself. So the closure properties inside the definition of binary operation. That's why I made a little bit of a big deal that when you multiply two complex numbers, you still get a complex number. It's the same concept here. So the notation that is used for binary operation is this asterisk symbol, and he uses it in the book. And that's why I think when people first see abstract algebra and then they see the example of Z5, it just, you know numbers. So you see plus as the binary operation. For the first thing that throws students in the undergraduate level is you got a plus, but that looks like a times. And so for a while they're like, why are you using that star to mean plus? Because star means times. So after a while you tell them it's not times, they start to understand, okay, but still that whole idea of this is just something totally different eludes them for a while, because you have to get used to it. So for example, in the case where we had a unit circle, if you take two elements that are on the unit circle and multiply them, they still will be on the unit circle. And S1, I looked through the book quickly. I don't see a notation for S1, and I realized just right now that I probably shot myself in the foot because he's going to use S1 to mean something else a little bit later, the symmetry groups. So I have to come up with a different notation for unit circle. It's true, and you can prove it, right? If you take two elements that are on the unit circle, they have to be expanded as Z1 equals e to the I theta 1 and Z2 equals I to the theta 2. If I multiply them to each other, then that new element also will have magnitude 1. So that's the criteria for being on the unit circle. So yes, this is a multiplication on the unit circle is a binary operation. It satisfies the definition. I take two elements, cross them, I get another element that's still on the set. Okay, any questions so far? Okay, let's go to something a little bit more weird. Let's look at how we can maybe pair the two-string braids. Well, I'm going to pair them in the following way. If I take braid 1 and braid 2, like so, and put it right underneath braid 1, the first thing I'm going to do, I'm just going to remove the bottom rod here from this one over here, and I'm going to remove the top rod from this one, and then I'm just going to attach the two braids. So that's how I'm going to glue two braids together. So if I do that, let S be the set of two string braids. Is this pairing a binary operation or not? Will I always get a two-string braid? Is it possible for me to get something funky happening? I'll always get a two-string braid if I glue them together in this way. I don't want to like go on if you're still, because this is new stuff, right?
No.
Okay. So that's the result. When you glue them together, you get this object over here.
Two-string braid has defined like left or right or something?
Two-string, no, there's no left or right. The two-string braid is exactly the object that I showed you, that it's pinned on top, strings are down, pinned on the bottom. That's
Ordered? It's not ordered?
What do you mean ordered?
Like that you would be able to, when you combine them, to know, because there are two different ways to combine them, right?
Right. So that, you know what? That's a good. You have other, I'm sure, meetings and things that you want to think about something else instead of the meeting. You can think about if that's true. If I turn around the order, would that turn out to be the same string at the end? It's a good question. That's why we take things like abstract algebra, to occupy our minds. This procedure is a binary operation because any pairing of the two-string braids is another two-string braid.
Isn't it true, based on what you said, that the result, you might get two different results?
It has nothing to do with the definition. All you need, by definition of binary operation, all you need is, let me go back to the definition, is that it pairs together two elements from the set and it still remains in the set. That's a definition of binary operation. So we haven't gone into any further definition. This is the only definition I'm concerned with right now. So if I take a two-string braid and I glue the other two-string braid to the bottom of it like this way, in that fashion, it's still a two-string braid. So therefore, that gluing function is a binary operation.
So uniqueness of the result is not important.
No. That has nothing to do with this, right? It just says that if I take two objects and glue them together, is it still in the same set? Yes. So if I wanted to do braid 2 plus braid 1, I just change the order of how I'm attaching them. So at your desk, just give it a shot. Take this braid and then star this braid. Reverse this one, attach this one. Just try it out at your desk and see what you get. So I think everybody could get that far, right? So what some people noticed is that you actually get just two strings hanging down. And where you get that is, so it depends on how good you are with geometry. I actually had students in the 103 class with yarn playing so they can see it. What you really see here is that when you attach those two strings, you're able to remove the crossing completely, because if you pull the left side and then pull the right side, you will get exactly those two strings hanging down.